Let's take a look at describing angular motion, or in other words, rotations. So angular motion involves an object, give me a second, change color here. Involves an object spinning around a fixed point or axis. So if I have, for example, a water bottle here and I rotate it, you can kind of maybe see the lid rotating, that's spinning. It would also be spinning if I go like this. It's just that the axis of rotation is now kind of in the middle here. So that's what we're talking about with spinning. And it's similar to circular motion, but there are some distinctions that will become clear as we go further. So if we want to talk about how we measure these rotations, we're typically going to be using angles. So the angle of rotation describes how much the object has spun. So obviously a bigger angle means a bigger spin. So I think people should be familiar with this from math, but if not, we can talk about it more in person. Just flag me down in class and we'll talk about it. So if we started with a stick kind of over here to the right and it's pivoting around the left side here, if it rotates to here, then we can see that there's this angle that we've rotated through of 90 degrees. And we can keep going, get to 360 degrees, continue going, get to 720, and continuing going around and around. And that's where we talk about the angle here. In physics, we're representing angle with the symbol theta. So that's the Greek letter theta. And a full rotation can be measured as either 2 pi radians or 360 degrees. And that should be something hopefully you're familiar with math, and this lets us switch back and forth because we can just take our radian number and divide by 2 pi, then multiply by 360, or vice versa to switch back and forth between them. In physics, we typically use radians when we're talking about rotations. So if we're talking about things rotating, we're typically going to use radians. Sometimes you'll see full rotations or revolutions, but for the most part, we want to be thinking in terms of radians. Now, why do we want to talk about radians? Well, it's because when we start measuring things, it'll end up getting easier, which we'll see on the in a later video. So like kinematics, we can have an angular velocity and an angular acceleration. So if we think about the angle as being kind of like a position, right? How much, like where are you located, how much have you turned? Just like with positions, where are you located, how far have you traveled? We can use that same idea to talk about angular velocities and angular acceleration. So angular velocity is how fast and in what direction. So typically you'd think clockwise or counterclockwise. What direction an object is spinning. The variable we use for this is the Greek letter omega, the lowercase omega. So it's kind of like a loopy W. Look it up online if you're not quite sure. And the equation that we would use, or that we're going to use in this class, is that the average angular velocity is equal to the change in theta divided by the change in time. Just like with average velocity is the change in position divided by the change in time. Same idea here. Angular acceleration, on the other hand, is how quickly and in what direction that spin is changing. So if it's rotating more and more and more in one way and getting faster and faster and faster, that would be one, the description of how that's happening would be the angular acceleration. If it's rotating in one direction, but it's slowing down, then we know the angular acceleration is the other way. And the variable is alpha, the Greek letter alpha. And the equation that we use for this, you might be able to guess it. but it's change in omega divided by change in time. And if that's not clear, this top thing should be the omega, the angular velocity. So this is something that will be easier to kind of show a couple things in class about how we talk about with directions and stuff like that, but at least now you've got an overview of how we measure this behavior.